che mamari nina. Tura la ba. Kofana, lana, tula ba.
Exploring the unknown has been a challenge for explorers over the centuries. As the machines blaze a trail across the solar system, we can see the sun, moon, and planets with more clarity than ever. It is as though their cameras are our windows on an extraordinary journey. We can see the cosmos through their eyes. Thanks to the invention of spaceflight, we have access to a variety of alien worlds and new territories. The night sky has been a window to a larger reality since the dawn of humanity. According to our ancient ancestors, the heavens above were evidence of something beyond. They were inextricably linked to life on Earth. Our ancestors observed the sky night after night and year after year, wondering what those changes might foretell about their destiny. There were a few changes that were easily observed. Constellations drift from east to west, like the nightly drift of the constellations. This is like the lunar phases of the moon that march from east to west. In addition, there were more fleeting changes, like colourful aurora borealis displays. From our ancestors, no change attracted as much attention as the complex dance of a few sharp objects moving around among the constellations. Although they looked like stars, their motions made it clear they were not. In Greek, they were called planets or wanderers. Throughout history, astronomers have puzzled over the motions of these planets and attempted to understand how our universe works. We could not see how particular the planets are without the invention of the telescope. When the telescope arrived, it opened up a whole new view of the universe, transforming the planets into distant worlds orbiting around the sun from just lights moving in the sky. It helped us understand that we are part of a solar system full of planets, asteroids, comets, and more. Any telescope can only show us a limited amount of the solar system. What happened next was the most exciting part of Loaded and Verified. A breakthrough technology was poised to reveal the planets to us like never in the 1960s. Because of spaceflight, it was no longer necessary to have better views of distant planets. Instead, you could see moving planets through the windows. Scientists on Earth got a taste of what it would be like to visit an alien world from this experiment. The first space voyages beyond Earth were directed at our nearest neighbour, the Moon. Soon, space probes crossed the great ocean of interplanetary space and sent back images of Mars and Venus. In addition, the first images of the hidden far side of the Moon were taken by the Soviet spacecraft Luna 3. The possibilities were endless. Mercury's surface has also been baked by the Sun. NASA research even farther to the distant outer planets in the 1970s and 80s. The most famous mission, Voyager 2, visited 4 giant planets in a row, including Jupiter, Saturn, and Uranus, before reaching Neptune in 1989. In recent years, the second wave of missions has allowed us to see the solar system from new perspectives and provided us with a robust new understanding of many planets. Sometimes that perspective means more detail and complexity than we ever imagined, such as these cloudy swirls in Jupiter's turbulent atmosphere. The icebergs could also be on Jupiter's moon, Europa's surface. There have been other cases where spacecraft revealed more history than we could have imagined in this barren Martian desert crater. The rim of the crater contains layers of ancient rock. These layers have been read like pages of a novel by geologists, and the story they tell describes long-vanished waters that once dissolved an alien landscape. The rich information, perspectives, and valuable data we receive from so many planetary missions show how diverse our solar system is. Additionally, we know that these very different places in the solar system have a common origin. The evidence shows that our Sun was born from an interstellar cloud of gas and dust some 4.5 billion years ago. Today, we can observe the same process in our Milky Way galaxy with the Hubble Space Telescope. We see what appears to be a gorgeous nebula of glowing gas, but it is actually a star factory, and our Sun was born there. There are unique characteristics for each member of our solar system family. As matter swirled together to form our newborn star, the Sun was not created in isolation. This matter ended up in a disk of gas and debris spinning around the infant Sun. Planets, moons, asteroids, and comets were born from the disk, like different children of the same parents. How did these solar system objects take different paths from the same essential ingredients? This is one of the big questions in planetary science. There was only one pathway that led to Earth, as far as we know. The Earth has the potential to sustain life. That life has been protected by it. After experiencing this, I began wondering about the solar system. We will not stop exploring. Our journey will also end at the starting point, knowing where we are. All the planets in our solar system share these traits, all the moons, all the asteroid bodies. Putting together these stories will also help scientists understand how we got here. On our own, at our own pace. We all face these questions. How we go about addressing them is described as well. The process has begun. Our solar system has many epic and beautiful destinations waiting to be explored, but none is more terrifying or beautiful than this hellish realm of searing, writhing, and dancing fire. We're talking about a vast and volatile powerhouse whose explosive explosions can reach thousands of miles into space, rattling our tiny world. The Sun is our star. Our entire living world and civilization depend critically on its power. Life as we know it would not be possible without the Sun's warmth and light. Even in ancient times, they regarded it as God. Our Milky Way galaxy is filled with hundreds of billions of stars, including the Sun. For us, the Sun is the most important star. Our solar system has 8 planets, several dozen moons, hundreds of thousands of asteroids, and possibly trillions of comets. Despite this, there is only one Sun, and it is 1,000 times more massive than the rest of our solar system combined. Everything is kept in orbit by the gravity of the Sun. The Sun always takes center stage wherever you are in the solar system. Galileo, a 15th century astronomer, was convinced our solar system was centered on the Sun, not the Earth. To defend his radical view, he was tried for heresy. Besides pointing a telescope at the Sun, Galileo made another surprising discovery. The Sun sometimes develops dark patches that seem to drift across the surface of its blazing surface. Eventually, astronomers learned that a subtle pattern governs the appearance of sunspots. On either side of the Sun's equator, they increase in number over an 11-year cycle. They cover all regions of the solar surface as they extend north and south. Each reaches its peak and then diminishes, and the cycle starts. It is clear from sunspots that our solar system is not just a simple light bulb, but a dynamic and complex one. There were hints that the Sun is more than meets the eye, even before Galileo's time. The most obvious occurs every time the Moon passes directly in front of the Sun, resulting in a total eclipse. An eclipsed Sun is surrounded by a glowing cloud of white light called the solar corona. In the highly ionized outer atmosphere of the Sun, ionized gas is energized to a much higher temperature than at the surface. The corona is also constantly changing, just like sunspots. Scientists could not explain where the Sun's energy initially comes from for generations, because these clues suggest it releases its energy in complicated ways. An unexpected side effect of the atomic age followed. Scientists have discovered how sunlight is produced by discovering nature's hidden nuclear forces. The Sun is mainly made up of hydrogen gas at its surface. As with most stars in the universe, the gas is about 5,600 degrees Celsius, hot enough to emit a bright yellow light. Temperatures reach millions of degrees in the Sun's core, and hydrogen atoms can combine to form helium under these extreme conditions. As energy is released from the Sun's core through overlaying layers, it gradually escapes into space. Our planet receives only a tiny fraction of the Sun's total energy. Suns are not always benevolent, as there is ample evidence to prove it. It has remained steady for eons, allowing life on Earth to flourish. Solar flares, which produce dazzling aurora borealis displays and giant explosions on the Sun, have long been known to scientists. For scientists to understand the Sun's changeable nature and how it influences the Earth, they must venture into space. It is possible to observe the Sun around the clock, and in ways not possible from the ground. As a result, astronomers have been able to study the rotational surface of the Sun over a long period. Using a circular disk to block the Sun's light is a less direct method of studying solar activity from space. Creating an artificial eclipse inside the spacecraft makes it easier to observe dramatic changes in the Sun. This method was used for years by the SOHO spacecraft. Comet-like particles are hurled at SOHO by a swoop of high-energy particles. Occasionally, a vigilant spacecraft will catch a trespasser. A transit of Mercury across the Sun can be seen here. Space views reveal an incredibly dynamic Sun connected from surface to corona by an invisible force, magnetism. Magnetism is the most potent force in the solar system. As a turbulent, electrically charged fluid, the Sun is not a solid body. The motions of that fluid create the Sun's magnetic field. Fields such as this poke through the solar surface and form loops that extend into space. Sunspots are created when material that would typically turn over and sink back into the Sun's interior is temporarily held at its surface and allowed to cool and darken. Solar magnetic fields can store enormous energy in their loops and twists. This energy is released rapidly and violently. Solar flares are the result. SOHO captured these photos of one of the most powerful solar flares in history on October 29, 2003. A vast region of magnetic activity first appears on the left-hand side of the Sun. As high-speed charged particles hit the spacecraft's camera, this region gradually moves toward the center of the Sun, where it explodes in a flash of light and burst of static. But a powerful solar flare can quickly destroy it. A coronal mass ejection is another hazard often associated with solar flares. As a result, there is a massive release of magnetically energized particles from the Sun's corona. Once they encounter Earth, the particles travel at high speeds through space. Particles cascade onto the atmosphere around the north and south poles, producing brilliant auroras. We have learned that the Sun is not an isolated and distant part of our solar system because of the age of space exploration. Earth travels through the Sun instead, and it is not just Earth that experiences this. The Sun is beside our planet and all other planets in our solar system. As a result, we are separated from the flow of interstellar material that permeates the galaxy with the Sun by a giant bubble. It is not just a star that we have. Stars surround us. As children of the Sun, there is also a connection between us. Each planet was created from the same primitive mix of atoms that formed the Sun billions of years ago. Since then, each planet has gone its way, sharing its own unique story. Discovering what lies beyond the horizon has challenged explorers for generations. In spaceflight, we explore alien worlds and discover vast new territories. The intrepid machines blazing a trail for us across the solar system today allow us to see the Sun, Moon, and planets with penetrating clarity. Through their cameras, we have been granted unprecedented access to the universe that they have discovered. To the human eye, our universe comprises light. It is the sign that matter is found in stars, galaxies, and vast expanses of glowing gas. Life cannot exist in this colorful world of gas and stars. The sweltering temperatures in space that produce gaseous glow are too extreme for life to survive. A strange environment is what life needs. It needs solids instead of gases. Rocky planets are ideal for life. There is no guarantee that life will take root because you have a solid foundation. There are many rocky worlds in our solar system. It would be impossible for life as we know it to exist without planets made of rock. Mercury is first on our list. It rotates slowly in the glare of the Sun, alternately baking and freezing. Mercury is the closest planet to the Sun, and its surface temperature can reach over 420 degrees Celsius during the day. The temperature can drop to minus 180 on the planet's night side, when the heat is rapidly radiated into space during long months of darkness. Until the beginning of the 21st century, Mercury's only visitor was the Mariner 10 spacecraft. We got to see Mercury's battered and baked surface up close for the first time. Mercury aims to orbit it and conduct the first comprehensive survey of its geological features and mineral composition. The spacecraft's view of the planet was incomplete, since less than half was visible. NASA launched Mercury Messenger in 2004. Messenger's images, at first glance, seem to depict a desolate lunar landscape. Mercury's surface was blasted by an enormous crater-forming impact, kicking up debris. Among the craters are some giant cliffs and escarpments. Mercury is known for them. The wrinkles may have formed because of the planet's giant metal core cooling and contracting. In Messenger's first images of Mercury, one can see only the bare bones of a rocky world. Over eons of geological time, nothing much has changed here, except the surface. This planet does not have an atmosphere. Mercury may provide some beginnings of a stable platform, but it is far too hot and barren to be anything other than an empty stage. In order to turn a dead planet into a living one, more than just an atmosphere is needed. Another rocky world, Venus, is mysterious. Venus was hidden from astronomers for centuries because of its dense, cloudy atmosphere. We now know that Venus's atmosphere consists mainly of carbon dioxide with sulfuric acid clouds. The Sun's energy is trapped by carbon dioxide, heating the planet to a staggering 466 degrees Celsius, making it even hotter than Mercury. The air pressure on the surface of Venus, even though Venus is twice as far from the Sun and its atmosphere is extremely dense, is so high that it would easily crush a human astronaut to death. It is easy to be deceived by first impressions. Countless meteorite impacts over billions of years have left the surface rough and heavily cratered. Mercury is so heavy that it is probably almost entirely composed of metal. Mercury's mass is twice as great as our Moon, even though it is slightly larger. Scientists have speculated that Mercury was a much larger planet whose exterior was shattered mainly by a collision. The result was a thin, rocky mantle surrounding a substantial metallic core. Mercury once bubbled and rumbled with the heat coming from a tumultuous internal formation. Several features show a volcanically active past. Underneath the more recent impact craters, we can see multiple ripples. Waves on the surface were frozen in time to reveal vast pools of lava that had once covered the planet. A blue area represents an ancient terrain gradually buried by orange-red debris. This image emphasizes Mercury's long history via false colors. Venus's extreme conditions have only allowed a handful of Soviet landers to take brief glimpses of its surface, none of which have survived for over 2 hours. Scientists had to devise other ways to explore Venus's remote terrain, with a planet so inhospitable to spacecraft. Radar can penetrate the cloud cover and bounce off the rock below, providing a detailed view of the planet's bizarre and dramatic landscape. Images like these reveal a volcanic world that may still be active today. Venus's surface appears to be black impact craters, which differ from what we see on Mercury, which shows that Venus is young and is likely to be continuously developing. Scientists now suspect that Venus might have been more like our planet in the past. Despite this, Earth's atmosphere warmed, destroying a vital part of its uniqueness. There is water in it. Our planet's oceans have played an instrumental role in keeping it suitable for life on Earth. Additionally, the oceans lubricate Earth's rocky surface and moderate the climate. It is primarily the planet's internal heat that moves the continent slowly. As on Venus, heat could build up without water and burst out in massive lava flows. Oceans provide an environment where molecules can interact in a liquid medium. Certain conditions can transform mere chemistry into life. A planet with all three ingredients, a solid surface, an atmosphere, and oceans of liquid water, has the potential to create something new. This could be the emergence and evolution of life. Our planet Earth is a shining example of what rocky worlds can do. Earth's wildlife is diverse and complex. Additionally, it has buried its tracks, making it difficult to understand how the planet came to be the way it is today. The technology is now available to explore the rest of the solar system, which is why scientists are so eager to do so. We may find clues about what Earth was like before life appeared and how the process took place here. Maybe We can only fully comprehend who we are when we reach across the ocean of space to distant, rocky shores. The view of a full moon is perhaps the most haunting and beautiful in all nature. There is something both familiar and mysterious about it. A natural phenomenon. Still, it is unique. Today we find an alter ego in our nearest neighbour, not a mirror image. We have memories of the violent beginnings of our solar system and Earth's turbulent past throughout history. While Earth looks lush and colourful, the moon is a study in black and white. While the Earth's surface is shaped by water and air and is filled with the sounds of life, the moon is silent and still. Neither rivers nor winds blow on the moon. That is all there is. The moon has been Earth's silent partner for billions of years, keeping watch from above and keeping its secrets to itself. Since humans are not very satisfied with that, every civilization in history has a myth about how the moon was created. The story took a fortunate turn with space travel. There have been over 50 spacecraft that have passed by, orbited, or landed on the moon. Viewed up close, the moon's surface is dotted with impact craters. The moon is formed when minor asteroids collide with the surface at high speed. Massive impacts produce enough energy to liquefy and hollow out craters many times the size of the original impactor. The debris will also travel thousands of kilometers. Our planet has taken just as much abuse as the rest of the solar system over billions of years. Earth's impact craters are eroded or buried in sediment. Our solar system's hazardous nature is displayed vividly and precisely on the moon, where they accumulate. The number of craters on the moon can determine which parts of its surface formed first and which later. We can see, for instance, that the dark patches on the moon are younger than the bright areas surrounding them. Maria Latin for seizure was the name given to these dark patches by astronomers in the past. It is clear from up close that there has been no water on these alien shores. Maria is a vast, low-lying plain of volcanic rock, because these plains are richer in iron than other parts of the moon. They were covered with hot lava spilling from the moon's interior. This contrast makes them appear darker. The mapping of both sides of the moon's surface is a significant accomplishment of lunar exploration. The moon rotates in sync with its orbital period, with one side facing Earth constantly. This resulted in two different sides. Despite Maria, on the side facing Earth, the far side of the moon is much less contrasted. The strange sideness of the moon is because of its crust, which is significantly thicker on the far side. A few more significant impact sites are scattered among the ancient rugged terrain. Researchers now believe that billions of years ago, when the moon's internal heat forced lava up, it found a shorter route to the surface on its near side. When and how did those circular plains form in the first place? This question is answered by lunar samples returned by the Apollo astronauts. The samples show that the moon's Maria was once the site of enormous effects, some of which date back approximately between 3 billion to 9 billion years ago. The solar system was more crowded with debris in its history than it is now. A storm of asteroids appears to have swept through the inner solar system, pummeling all the planets and the moon. It left gigantic circular scars on the moon and Earth, but it caused far more damage on the moon. While no animals or plants lived on Earth, the effects would have vaporized oceans and liquefied extensive areas of our planet's crust. Microorganisms may have already appeared. Maybe only those microbes living deep down near deep sea vents survived the bombardment and became our distant ancestors. Astronauts have returned significant samples to Earth after bombarding the moon and the Earth. Perhaps the biggest surprise is the revelation that the moon was once the result of a giant collision. A large object as large as Mars collided with Earth early in our solar system's history and caused our planet to suffer a staggering blow. In the first moments after the collision, vast amounts of debris were thrown into orbit around Earth, eventually coalescing to form a single large moon. It may seem incredible, but this giant impact scenario offers the most plausible explanation for some of the moon's more puzzling characteristics, including its apparent lack of iron core. Because of the moon's presence, the tilt of the Earth's axis is stabilized, preventing climate swings that would devastate human life and civilization. Ironically, the destructive birth of the moon may have played a crucial role in maintaining Earth as the cradle of life in our solar system. The Moon's history is closely intertwined with our own because of its formation. Life may have developed differently without the Moon. Without the Moon, we might not even exist. We have gained a fascinating perspective on the past by exploring the Moon. For the US, China, and others, the Moon may also be the gateway to a bright future in space. There are now efforts underway to return humans to the Moon's surface. The goal is ambitious, but it is also a stepping stone to more distant destinations. We still do not know where the next human mission will land. The Moon is not short of exciting places scientists would love to explore. A visit to the lunar South Pole is undoubtedly at the top of their wish list here. The sun never shines on some craters' floors, always in shadow, cold enough for water vapor to condense in these dark craters and even form lunar ice. It is possible that comets colliding with the Moon's surface could cause the water vapor to appear. A recent study found hydrogen in many craters on the South Pole. This is robust evidence of ice. Ice on the Moon could provide explorers with much-needed water, if enough of it. Moon tells us that this world is just one among many in the solar system. It will be a challenge to find and retrieve the ice, since you will have to venture into perpetually dark areas. A new exploration of the Moon could pave the way for even more daring explorations on Mars and beyond in the future. Discoveries beyond the horizon have challenged explorers for generations. Exploring alien worlds with vast new territories is possible thanks to the invention of spaceflight. We may also visit them one day if we are determined enough. Our intrepid machines are blazing a trail across the solar system today, allowing us to observe the Sun, Moon, and planets in unparalleled clarity. Their cameras have become our windows into a bold and exciting world. These discoveries have become our cosmic vistas when everything is strange and exotic. Home is where we belong. When exploring the solar system, Mars is a familiar destination. It is a strange planet. The surface of Mars also has recognizable features. There are deserts and dunes, cliffs and canyons in this world. We can imagine ourselves exploring this landscape firsthand on 2 feet or 6 wheels. Mars is not easier to understand when it is familiar. Mars is better known to us than any other planet in the solar system, except ours. We have studied its landforms from orbit and sampled its soil and rocks from the surface. Its complex history and present state have only increased our questions, including the most important one of all: is there life on this planet? Our journey takes us to the borderland. There is no abundant life on Mars like there is on Earth. As well, there is no chance for life on the Moon. Mars is somewhere in the middle, so we can pinpoint where life is possible and not. The status of Morris Borderland is not revolutionary. More than a century has passed since astronomers first speculated about the possibility of life on Mars. Scientists were surprised and disappointed by the first close-ups of Mars broadcast in 1965. Images of the surface showed it was cratered and barren, much like the Moon. The red planet was the dead planet, and any possibility of finding primitive life on its surface was all but wiped out.
Che mamari nina. Tura la ba. Ko phana lana tola ba. Papa na, Nana, Jai Mama Nina.